Hello everyone. The topic is grey water treatment system. In this treatment system, we have designed one filter for treatment of grey water. Water. Water is the most important part of our life. We get water from streams, lakes, wells, and oceans. We use this for industrial purpose, power generation, irrigation. At home, we use water for washing, cooking, and drinking purpose. If we see the global scenario, less than 3% of water is fresh and rest is saline. To overcome the water scarcity, we can reuse the wastewater, we can minimizing the use of water, or we can go for rainwater harvesting. If we choose the reuse of wastewater, we can go for grey water. Grey water. The wastewater produced as a result of household activities like bathing, from kitchen sinks, wash basin, and laundry is classified as a grey water. 700 liters of grey water generated per household per day in India, and total 249 million of households is there, and it does not include hotels, hostels, institutions, and other commercial setups. So around 200 billion liters of grey water is generated in India every day. The characteristics of grey water vary depending on the number of family members, their age, and usage. The grey water generated from bathroom consists of high amount of shampoos, soaps. Laundry grey water consists of high levels of detergents. Sink grey water has a contribution of soap and toothpaste, and the grey water generated from kitchen sinks have a high amount of food residues, oil, etc. The figure shows the contribution of various sources of grey water. So what is the need for the treatment? India, being a highly populated and tropical and drought-induced country, has a need for the development of grey water system, because grey water consists of suspended solids, high pH, high turbidity, bacterial contaminants, and this can be a direct or indirect harm to the both animals and plants. They can be a cause of various diseases, and publicly the grey water is not accepted. In this study, first we have characterized the grey water. We have collected the grey water from drain pipes, then characterization from individual sources, and from overall mix grey water is also collected. 3 samples per month we have collected after every 10 days, and it is analyzed in the lab for pH, COD, BOD, turbidity, TSS, and chlorine. And study was undertaken over a period of 6 months. For treatment studies, we have designed one filter system. Different layers of materials such as sand, gravel, fly ash, banana peels, wood chips, and coconut husk were used. The filter unit was composed of a height 100 cm and width 30 cm. We have used sand filter layers, fly ash, brick clumps, coconut husk, wood chips, and banana peels. This is our schematic representation of filters. In our results, characterization of raw grey waters, we found that the characteristic depends on the number of members in a particular household, the season, the storage time, and collection time. Increasing the members in a household increases the amount of grey water produced, and it also increases its contaminant level. The season also plays a major role in the variation of parameters of grey water. During warmer climate or humid climate conditions, the value of BOD increases. The amount of grey water produced was more during the morning hours, and the varying nature of different soaps and detergent changes the parameters drastically. The removal capacity of filter which we have prepared is given in this table. So percentage removal of BOD, COD, turbidity, total suspended solid, and chlorine is mentioned in this table. The filter work efficiently for a duration of 80 days, and after that ports started blocking in the sand filter and efficiency was reduced. Applications and reuse. The plan for greywater system and reuse system applied to a single household is given in the study. A freshwater inlet is provided to kitchen sink, wash basin, washing machine, and in shower. The greywater generated from these points is collected by pipelines and stored in a collection tank. From the collection tank, the stored greywater is transferred to a filtration system, and after filtration, it is collected in a reuse tank. This greywater can now be reused for different purposes. This figure shows the plan of greywater treatment system. Applications and reuse. A small study of irrigation was also performed. Fenugreek seeds were planted in pots of 2 kg soil capacity and two plants were evaluated. One was provided fresh water and other was provided the treated grey water. Same growth was observed in both the plants with the same leaves color and same lifespan. Some other applications of grey water is green ambulance, construction of roads and buildings, firefighting, hotels, and golf courses. We can use this grey water at these places. So last, the designed filter found to be very useful for treating in-house generated grey water. Characteristic studies show that the parameters defining the quality of water differ according to the different sources of grey water and variation of region. It can be scaled up by making the unit more robust, and it can be recycled and reused for the purposes such as toilet flushing, gardening, car washing, firefighting, etc. Practice could lead to a significant reduction in consumption of fresh water. These are some references for our study. Thank you.